Hi everyone, so today we're going to talk about surface area of complex polyhedrons. Now, you guys did an okay job on rectangular prisms, but I do want to review just one quick example of that. And we're also going to move on to cylinders and square pyramids, which we also touched a little bit on today, but I think visualizing the nets of these kinds of shapes will work much better to helping you understand them. So our objectives for today are we're going to break down the polyhedrons, which are our 3D shapes, into polygons, which are 2D shapes. And basically what we're doing is we're going to smush the polyhedrons down into their basic format or into a shape that we can see all of the sides at one time. That'll help you to visualize what areas you need to solve for in order to find the total surface area of a three-dimensional figure. So I've got a couple formulas here: a rectangular area, the area of a circle, and the area of a triangle. I think today we spent sufficient time on the area of a triangle being 1/2 times the base times the height. But what I'm not sure if you really understood was that when you have base times height, you are basically finding the area of a rectangle, right? Rectangle area is length times width, or width times height, as it says in that formula above. Area of a triangle is base times height, but it's 1/2 of that area. So what I just wanted to demonstrate was that if you insert a triangle into the inside of a rectangle, that particular shape, will take up about half of the area of the rectangle. And we can actually prove this. This is true. So if I go ahead and I fill in the area of my rectangle that's not used in the triangle, fill in that shape. And on the other side as well, I can fill in that area. And I can reposition that area to the inside of my triangle, now showing that that area takes up the same amount of space. Approximately, it proves to me that 1/2 of the area of a rectangle, which is built around a triangle, will be the area of the triangle. And you can see that because the height of the triangle is equal to this vertical height that they give you as a reference point. So you are really looking at 1/2 of a rectangle to be equal to the area of your triangle. And I just wanted to make sure you guys made that connection, okay? So as we move on, like I said, we're going to do a couple of examples. So I wanted to give you a better picture of finding the surface area of a rectangular prism. Now, we know that a rectangular prism has 6 surfaces, but I don't know if you really understand how this works, so I just wanted to show you this little animation. I really love this website. I'll post it up on Podium so you can see it. But it builds the box for you, and it shows you the measurements, and then it unfolds the box and shows you the net. Now we have the net of the rectangle right here. And this net is made up of smaller rectangles. Well, we know what the area of small rectangles are. We just multiply length times width. So for each rectangle, you can go ahead and find the area. 3 times 5 is 15. 4 times 5 is 20. 4 corresponds to this side. 3 corresponds to this side. So 3 times 4 is 12. 5 times 4 will be another 20. 3 times 5 is 15. 3 times 4 is 12. So I've got the area of all of the surfaces of the rectangle. I just need to find the sum. I just need to add those up. So I have 20, 20, 12, 12, 15, 15. I'm going to be at a total of 94 units squared, okay? And that's the surface area of my rectangle. So this is much easier, I think, when you break it down and you can see the shape as a whole. Moving on, we also want to take a look at the 3D pyramids, the square pyramid. In the animation, we have what is the square pyramid kind of rotating and giving us a good look of what that looks like. And also the net of the pyramid opening and closing and folding on itself. And as we can see, the pyramid is made up of a square and 4 triangles. So in order to find the surface area of the pyramid, you need the area of the internal square, or the base, and also the area of one of the 4 triangles. You can use that area over and over again, multiply by 4, because all those triangles are the same size. Okay? Finally, the last piece of finding the surface area of polyhedrons has to do with the surface area of a cylinder. Now, I have the formula for the area of a circle, which is pi r squared. Now, the symbol pi represents the approximate number, which is 3.14. Now, that number represents a ratio of the circumference of a circle, or the distance around the circle, compared to the measure from its center to the edge. This is actually a Greek symbol. It was invented, not invented, but discovered very early on in mathematics, because circular shapes and domes and spheres were very common in early architecture, especially in Greece and ancient Rome. So pi is a ratio, it is a value. When I ask you to approximate an answer, you may insert 3.14 and solve. If you are ever asked for an exact value, so 3.14 would be your approximation. This is not the exact value of pi. If your exact value, you can use the pi key on your calculator, or you treat pi as a variable and you do not solve it. You do not manipulate pi. So when you insert numbers into the equation, you solve for all the numbers except for pi and include pi in your final answer. It's almost like keeping a number in fraction form instead of transferring it into decimal form. And I'll give you an example of that. But before we get there, I want to show you this animation. The surface area of a cylinder. A cylinder is a three-dimensional shape that has a base, which is a circle, and a top, which is a circle, or a lid, which is a circle. And each of those circles have an area of pi r squared. The circumference of a circle is 2 pi r. Again, these are pi r squared, pi times r squared, and 2 times pi times r. You have to remember that whenever a number is right next to a variable, it's representing multiplication. So what this animation is going to show us is that the distance around a circle is actually going to be the length of the rectangle which pieces together your cylinder. It's almost as though you're taking a can of soup, can of tuna, whatever you got, and unrolling the label from the can. When you unroll the label, it's cut in the shape of a rectangle, and you could see this rectangle forming. It's the yellow shaded area from the start to the finish of the distance of the circle. So the length of your rectangle is actually the circumference of a circle. In certain cases, when you're looking at the surface area of a cylinder, you may only be given the radius and the height. These are the only things you need to solve for the surface area of a cylinder, because you can use the radius to solve for the circumference, which will be equal to the length of the rectangle. So you do not necessarily need the length of the rectangle.